Hello friends, welcome to my channel. Let's continue on our series of stock buy and sell problems from Leetcode. So in this video, we're going to analyze the last problem, problem 714, best time to buy and sell stock with transaction fees. So the plan for this video and this last video for this series is the following. First, we're going to make connections for this problem with problem 188 or 122. And then we analyze the DP idea for this series and then provide two solution formats, so essentially one. And finally, we give a summary and share some thoughts to end this video. And before we do the analysis, let's first make a comment. So here, if we want to solve this problem as an isolated problem, so it's not hard. So with that said, let's look at the analysis. So as we mentioned, for this series of problems, so they are characterized by two things. First is the allowed number of transactions, let's call it capital K, and the other is additional constraints. For example, these are some information for this series of problems. Like in 188, so K is a generic K, and in problem 121, K equals 1. In 122, so K can be regarded as positive infinity. And in problem 123, so K is 2. And in problem 309, so K can be regarded as infinity, but the additional constraint is cooldown with 1 day. And in the current problem, so actually K can be regarded as infinity, and the constraint is that we need to pay transaction fees if we opening or closing a transaction cycle. So as we mentioned before, once we solved problem 188, so we can readily and easily solve all the other problems in the above list. So before we do the analysis, let's emphasize the connection of the current problem with the list of problems here, mainly 188 and 122. So this problem here is a variant of Leetcode 188 with K being positive infinity and with a transaction fee. If we want to solve this problem as an isolated problem, actually, besides the transaction fee, this problem is essentially the same as Leetcode 122. So also we could essentially reuse the code for Leetcode 188. So here we are going to reveal the analysis of Leetcode 188 to refresh. So because it's so general, so we want to make connections after we do the refreshment, and then we write the code specific to this problem here. So next, let's temporarily forget the transaction fees, and then we do the analysis. Let's assume that we allow at most K transactions, capital K. So this dynamical programming idea is essentially the following, consists of the following steps in the full detail. So first, we need to actually know the possible actions we can take at each day. So here we could consider buy, sell, or do nothing at each day. So in other words, if we do nothing, let's say we rest. So in more detail, so at a specific day, so if we have stock, we could consider sell or rest. If we do not hold stock, we could consider buy or rest. So for convenience of writing DP table in that problem, we use the one indexing for the prices or days. For example, S day, so I starts from 1. So S day is corresponding to index I-1 in prices. So this is step 1, the possible actions. Step 2 is DP interpretation and initialization. So actually this step is not trivial. So because different DP interpretations may lead to different recursion relations or DP update rules. And for some problems, actually the initialization is not that trivial. So here, So we are involved 3 index actually, I, K, and C, S. So S is state, so either we hold stock, that is 1, or we do not, that is 0, right? So I is the day, and K is the number of allowed transactions. So TIK0 is nothing but the max profit at the end of the I state, that's the I here, and with at most K transactions, that's the K here, and with no stock at hand after taking possible actions, that is 0 here. So the TIK1 is the max profit at the end of I state with at most K transactions with stock at hand. So that's the 1 here. So here again 0 no stock, 1 with stock. So after we taking possible actions, so that's the meaning of TIK1. So after we interpreted TIK0, TIK1, let's look at the initialization. So because we start from day 1, so for day 0, so there's no stock yet. So then for any K, so we set T0K0 to be 0. So this is the normal state. Because we have no stock and we end with no stock, so we set it to be 0. Otherwise, so T0K1, we set it to be negative infinity. The reason is that we have no stock, but we end with stock. So we can understand like this. As no stock, but 1 indicates with stock at hand. So here we could regard that we had bought a very expensive stock from nothing. And here nothing is no stock. So this is the one set of update for I equals 0. So another initialization is for K equals 0. That is no transaction. So for any I, so we are going to have TI00 to be 0. The reason is that we have no transaction, but we end with no stock. That's normal, so we have 0. And the other is TI01 is negative infinity. The reason is that we have no transaction, so we expect no stock, but we have stock at hand. So we can understand like this. As there is no transaction, but 1 indicates with stock at hand. So here we can regard that we had bought a very expensive stock from nothing. So here nothing means no transaction. So this finished step 2. So the interpretation of the DP table elements and the initialization. So if we have digested or grasped the meaning of TIK0 and TIK1, the DP update is not that hard, or in some sense straightforward. So let's look at the update rule. So here for I state, again I starts from 1 and ending at n, because we use 1 indexing for the ease of initialization. So let's first look at equation star. So we update TIK0. In other words, the profit at the end of I state without holding stock. So this can have 2 possibilities. First is that at the end of the I-1 day, we do not hold stock, right? So we can do nothing or rest at the I. That's the first item. So the second item is TIK-1 K1. So in other words, at the end of the I-1 day, we hold stock. And here at the I, we can choose to sell that stock. So we gain some profit. That is, this is a part of profit we gain. So in other words, we can do the maximum of rest and sell at the I state. So this is the equation star. And now let's look at equation double star. So for equation double star, that's the maximum profit at the end of the I state with stock at hand. So there are again 2 possibilities. First, at the end of I-1 day, we hold stock. And then at the current day I, so we choose to rest. So this is the first item. And the second item is that we do not hold stock at the end of I-1 day. So we can try to buy a stock at this I state. So if we buy stock, we pay price. That's why we have negative here. And also, if we buy stock, we triggered a new transaction. So in the previous I-1 day, the maximum allowed transaction is K-1, because we need to consider or count the current transaction mass. So that's why we have K-1 here in equation double star. So with that said, we are done the DP update rule or recursion relation. So next we are going to return. This is nothing to be explained, right? So with that said, we explained the general principle or general thought. So now we can look at the current problem. In the current problem, there are two things. First, k is positive infinity. So if we replace k in star and double star by positive infinity, so we notice that k and k minus 1 is the same, right? So essentially, so they become this equation. So we replace the k with star. In this format, now essentially only two routing variables, that is ti0 and ti1. So this is actually very good. It greatly simplified the recursion relation. So secondly, the transaction fee. So the transaction fee actually is very simple to incorporate. So we could pay the transaction fee either when a transaction cycle is complete, in other words, when we sell, or when the transaction starts. So in this case, when we buy, right? So if we use the former, so we could subtract fee from the second argument in the first equation and keep the second equation fixed. So in this case, actually we can, because we buy, right? We sell, so we can minus the fee, or we can subtract the fee from the second equation when we buy a stock. So we subtract fee. So in both of the two equations, if we want to take into consideration of transaction fee, we need to do subtraction. So that's it. So with this several lines, so actually we can write the code very easily. So in our previous videos, our route is like that. We first write a solution with DP table, and then we reduce the space to 01. But here, to save some time and to control the length, we're going to write solutions directly using space 01. So we are going to write two versions. So here, the number of n allowed transactions is k equals positive infinity. The reason we make this annotation is to align with the general series of problems. And also here in this version, I'm going to pay fee when sell, right? When we complete buy and sell circle. So this is actually very easy now. So we just use this recursion relation. First, let's make some initialization. So for this, I'm going to write with these symbols just to make connections. So tik0, so that is 0. So in other words, when we have no stock, so we set it to be 0. And if we have no stock, but we end with stock, so we're going to set it to be float negative infinity, right? So this is the initialization. So next, we're going to do the state update. So if we use DP table, this step corresponds to DP update. So we are going to look at each day. So for y in prices, notice that we do not need to specify the indices, right? So first, let's update this tik0 or 0. So it has two possibilities. That is, the max of tik0, its previous state, or the state at the previous day. So at this day, we choose to rest. This is one possibility. Another possibility is that the previous day we hold stock, and then we can try to sell stock. If we sell stock, we gain some profit, that is, we plus y. If we choose to pay fee when we sell, so we need to minus this fee. And actually the update for tik1 is the same so as before. So this tik1, the previous day state. And then if the previous day have no stock, we're going to buy. If we buy, we pay some price, that is y. So this is the state update. So now let's look at the return. So we are going to return tik0. That's it. So this actually forms a solution to this problem. The code is very short actually. So let's first do a special case check. Yeah, it passes a special case. Now let's look at the generic case. Yeah, it passes all the cases. So with that said, let's look at another slightly different format. Let's copy all the code, and then we change this to be v1, and then we do this. So here actually we can pay when we buy, right? So because a transaction cycle consists of buy and sell. So if we buy, actually it triggers a new transaction. If we sell, we finish a transaction. So here actually we can put this minus fee to be the second equation. So this is the second format. Then you can do the check. So it passes a special case, now generic case. Yeah, it passes all the generic cases. So actually you can practice to write a format with DP table. That's actually sort of straightforward. So I guess that's about the solution to this specific problem. So let's make a summary, because this is the last problem in our list right here. So the summary consists of two parts, two items. So the first item is that we can combine the constraint of problem 714 and 309. So we could consider both cooldown and transaction fees simultaneously. Or more generally, so we could consider general allowed number of transactions. Let's call it capital K. So following this line of thoughts, we could make up or cook up a lot of different variants of problems from the above lists. So essentially, all of them can be solved following the similar thoughts or line of ideas. So this is the first item for the summary. And the second is basically a thought. So here we use induction or deduction, or specification or abstraction. So from practice purpose point of view, so we could use a same principle or same idea to solve some common problems. Or we could solve one problem using different methods. So both might be very helpful in gaining a better and deeper understanding. So with that said, I guess that's the end of this video. Thank you.